Hello everyone, hello and welcome. This is Aurora with the Central Coast Astronomical Society, and we are going to be having a live stargazing session tonight. Are you ready? Our main feature tonight, we have with us Kent Wallace. Kent, are you there?
Yes, I am.
Woohoo! So Kent is joining us. He has been a member of CCIS pretty much since, I don't know, I think maybe I was 2. So Kent is one of the, your passion is Planetary Nebula, isn't it, Kent?
Yeah.
Awesome.
Yeah, I'm really a Planetary Nebula nut.
So Kent, I'm going to share your image with, I'm going to share a couple of pictures I have of Kent. Kent is actually joining us from a phone. So he's not looking at a whole bunch of star charts. He's just sharing knowledge and from his passion of astronomy. And he's going to be doing that over the phone. So we've piped him in. So you're not going to be able to see him. You'll see me, and you'll also see my screen, which is going to look like this. This is Stellarium. You can download it for free. Stellarium.org. I think Brian is going to put a link in the chat. Usually we get a bunch of questions about that. So you can download this, you put in where you live, and then it will orient what you should be seeing in the night sky. So we're going to take you on a tour using my desktop. Okay, so, but first, Kent, you have a telescope, right? What was that orange telescope you were telling me about?
Oh, I've got an old orange C8. There it is. Yeah, I really like that scope. I've used that for about 13 years before I got my 20-inch. In fact, that orange scope went, let's see, in 1999, I took it to Western Australia for 3 months to survey planetary nebulas on the other side of the sky.
Awesome. Awesome. Now, you mentioned a 20-inch.
Right. It's a 20-inch Dobsonian F5. I surveyed all the planetary nebula I could see from this side of the sky. Then I took 3 more trips to Western Australia. I actually had to air freight that scope, to a friend in Western Australia, then get a big station wagon to haul it out in the country and set it up for observing.
Wow, that's amazing. I mean, look at the size of the scope compared to you. Now, when you say 20-inch, we're talking about the diameter here, so not about the
that's
length.
Diameter of the mirror. In fact, you can see the mirror in the case there.
Yes.
That was a shipping case that I used to ship it to Western Australia.
Mm-hmm. Awesome. All right, Kent.
In fact, one thing, if you notice, the scope in the upper left is a different color at the base than the scope in the middle there.
Yeah.
And that's because I had to get a prototype breakdown structure to be able to ship everything and use it easily in Western Australia. And so that lower section and the tubes are basically stored in a shed right now, and I'm back to using the brown one.
Wow, that's awesome. That must have been quite an adventure. How many times did you go to Australia?
4 times, once with the C8, and then 3 times with the 20-inch.
Wow. And
it was beautiful, I'll tell you. It was nice seeing the Magellanic Clouds and all the wonderful things down on the other side of the Earth.
Wow, that's amazing. Oh, that reminds me, for those of you who have access to the chat box, can you type in right now where you're from? So this will help us as we talk about things that are in your hemisphere. So astronomically speaking, we'd like to know where on the planet you're located. So go ahead and just say hello, give us your name and where you're from. If you're outside the United States, please include your country so Brian can skim through that as well. And so if Kent has something that he'd like to share from your corner of the world, we'd love to be able to do that. Okay, Kent, are you ready? Well, should we get started?
Yeah, let's get started on the constellations.
Okay.
The ones we picked, there's 5 of them. Capricorn, which is a sea goat, half fish. Then the next one is actually a fish outright called Piscis Austrinus, which means southern fish. Above that is Aquarius, the water bearer. And then the next will be Cetus, which was the sea monster in the Clash of the Titans. And sometimes referred to as a whale, but in the classical mythology, it's the monster that was ravaging the coast of Ethiopia and was supposed to attack Andromeda, the chained lady. Then the final one above Cetus is Pisces. And so that region, general region of the sky, was referred to by the ancient Euphrateans as the sea in the sky, because it's kind of like a big water themed area. And those other ones further south are modern constellations. All 5 of the ones that we're covering are ancient Greek constellations. There's like 48 of the ancient Greek constellations, and there's 40 modern ones, making up a total of 88 constellations.
Mm-hmm. Awesome. Okay, great.
Oh, but I've got some mythology.
Yes.
You want me to?
Yes.
Yeah, there isn't a lot of mythology on all these, but there is kind of an interesting one with Capricorn in there, which is a sea goat and half fish. And the story goes, this is the Greek gods. So you had Zeus and a bunch of the gods there. They defeated the Titans. But after the Titans, something really bad came. It was called Typhoon. And it was such a bad monster that all the gods could do was run away. So they did the smart thing. Kind of like Monty Python and the Holy Grail. They ran away when things got bad, all the way to Egypt. And Typhoon followed them to Egypt, so they had to change their shapes.
Oh, no.
And Pan, which was half man, half goat, he changed himself into Capricorn, half goat, half fish, and jumped into the Nile. Also, Aphrodite and her son Cupid, they turned themselves into the foley fishes, and that makes up Pisces. What happened later on, they finally managed to defeat Typhoon after they figured out how to do it. And Zeus thought that Capricorn was so funny, being half fish and half goat, that he put the image in the sky. He just thought it was hilarious. And so that's why Capricorn's there rather than Pan outright.
How interesting.
And so that's part of the some of the mythology. There's a little bit of mythology with Aquarius. He's the water bearer. Evidently, it was thought in Egypt when he put his jug or urn in the water, it would cause the Nile to go down. And when he'd pull it out, then the waters would flood back in, and you get the flood. So he was tied in with the the rising and lowering, or the flooding of the Nile. And
interesting.
The southern fish, Pisces Austrinus, that goes way back. That's really an old constellation back to the Assyrians. They called it Dogon or something like that, but there's no neat story with it that I could find.
Oh, wow.
And so that's pretty much all the mythology for the 5 constellations that we're covering tonight.
Oh, awesome. Well, before you dive too deep, let me show people where to find this constellation, and then you will take it from there. So let's take a look.
Okay.
All right. So normally, wouldn't it be nice if the sky looked like this? It'd be so easy to find the constellations, right? That's not going to happen.
Yeah, unfortunately, there's no pictures superimposed.
No. So let's make it the way everyone else is going to see it tonight. So, okay, so here we go. I did leave my directions on because you pretty much can tell which way is north, south, east, and west, especially if you have a compass. So this
and
is...
the other thing, Aurora, that's cool is the for Capricorn, that's an HA ray drawing. For the outline, how they've got the stars set up there. The HA ray form fits on that pretty well, where it's kind of backwards with the one they've got there.
Yeah, he's facing the other way, I think, right?
Yeah, the horns are actually the tail in the HA ray image.
So
but
here,
then he doesn't really show a fish tail on it. It looks more like an outright goat in the HA ray. You've got the tail, you've got the backbone of it, you've got the horn out front, the triangular head, and then kind of like the feet together down low.
Yeah.
So that's the HA ray image of Capricorn.
Got it. Okay, and actually, that's the way I see it in the night sky. So real quick, you want to look south. And this one, if you do this tonight, you're in luck. Because as you notice, Capricorn is smack in the middle between Moon and Saturn and Jupiter. And so if we turn off these labels, here, let me turn off the planets too. Can you still see Capricorn? Here, I'll give you a little hint here. Take a look.
Yeah, I mean,
go ahead.
The thing that stands out to me is the tail section.
Yeah.
Because those are the brighter stars in Capricorn.
Mm-hmm.
And so that's where I usually hit those with my binoculars.
Mm-hmm.
And then I can work out along the back. It's like a long straight stretch there with the horn there. So that's what I work with when I hunt it down. And then you can work on the rest of it, the head and the feet down below.
Mm-hmm. Yes,
and
exactly.
So that works out pretty good. And actually, we'll talk about those two bright ones in the tail there.
Yeah, do you want to start with that?
Yeah, let's start with Alpha 1 and Alpha 2. It's actually supposed to be naked eye, bright pair.
Mm-hmm.
Binoculars, it becomes real easy to see. But Alpha 1 is actually the dimmer of the pair. And Alpha 1's a supergiant star about 500 light years away with a magnitude of 4.2, where Alpha 2 is just a giant star, and it's 109 light years away, but its magnitude 3.6 because it is 5 times closer. So it appears 25 times brighter than if it was at the same distance as Alpha 1. And so they're definitely not binary, being that,
No.
one's at 500 light years and the other one's at 109. But they both look yellow, and, it's just kind of a nice pair, definitely for binoculars, and if you've got sharp eyes, you should be able to split up Alpha there.
Yes. So just
and also,
go ahead.
Alpha 1 and Alpha 2, they do have companions. Alpha 1 has a magnitude 9.2 companion about 45 arc seconds away, and Alpha 2 has a magnitude 11 companion about 6.6 arc seconds away.
Wow.
So you'll need like an 8-inch telescope to actually see the companions for those two.
Mm-hmm. Got it. Now this one, just to reiterate, is Alpha 1. This one's Alpha 2. And we are looking right at the tail segment of Capricorn here. This is from your handout.
Right.
Okay, cool. Nice. And do you want to talk about Beta?
Yeah, let's go down to Beta because it's just kind of like at the base of the tail.
Okay.
For Capricorn there. And it's a nice blue and white double. They're separated by about 205 arc seconds, so that's a pretty good separation there. The white component is about the magnitude 3.4, where the blue component is magnitude 6.2. So it's quite a bit dimmer than the other one. And the double is located about 150 light years away. The white component is about 100 times brighter than our sun. And it's really easily separated in even a small telescope. So, you've got some color difference there. So it'd be a nice object in a small telescope.
Nice. Awesome. Now, there was another object in Capricorn, right? Like right off his nose?
Right off what they say is the mouth of the goat. Maybe he's getting ready to eat it. But, goats eat everything. Yeah, this M30, which is, we call it the jellyfish cluster. It's actually a globular cluster. It's about 30,000 light years away. Its magnitude 7.3, so you can pick it up as a fuzzy blob in binoculars. The cool thing about it is that it has these lines of stars going out from it, and that kind of looks like tentacles dangling down. And so visually, it looks like there's about 3 different lines of stars dangling off of M30. So that's where it got the nickname the jellyfish cluster, because of the little tentacles hanging down. Another way to find it is M30 is about 25 minutes west of Capricorn 41, which is a magnitude 5.5 star. And so you find 41, you just slide west, and you'll come across this fuzzy blob. And so that's M30.
M30, and then we have 41.
41 Capricorni, I guess.
Nice.
And that takes care of the Capricorn.
Perfect. Okay, so just to recap real quick, when you go out tonight, you're going to go south, look for that moon. Here, wait, let me mess it up. Hang on. Okay, here we go. Here, we shake it up. There we go. So we're going to go outside. We're going to go looking south. We're going to see the moon. We're going to see the planets. And then we're going to say, hey, there's a little tail section up here. You see that? Can you find the rest of it? Yeah, you see the back section is right up in here. Okay.
Yeah, it's almost like a wedge for the, pointing roughly towards the moon.
Yeah, just tonight though. The moon's gonna be in a different position tomorrow. Well, I guess the next couple of days it'll probably be okay. But
well, again, the moon moves quite a distance
it does.
each day.
It does. The other place you can look is we're going to talk about this star, but this is a really bright star here, and so.
Oh yeah. Do you want to go on the next one? That's Pisces,
yeah.
Strenus.
So just to go ahead.
Yeah, it's called the southern fish. That bright star is kind of all by itself. It's called Fomalhaut. In Arabic, it means the mouth of the fish. And it's also referred to as Alphas Piscis Austrinus. And it's a white star. Its magnitude 1.17. And it's fairly near. It's only 23 light years away. It's like the 18th brightest star in the sky, roughly twice the diameter of our sun and about 14 times brighter than our sun. And it's sometimes called the solitary one because it's the only fairly bright star in that whole southern part of the sky that you're looking at. If you throw out the planets and the moon and the other, like Mars, then it's pretty much by itself there in what they used to call the sea. And so Fomalhaut's just kind of all by itself, but it's kind of easy to find because it is by itself.
Yeah.
You want to go on to the next star?
Yeah. Let's talk about Beta or
which
Alpha.
That was Alpha.
That was Alpha.
We'll go to Beta.
Yes.
Beta Piscis Strenus, which is a double. It's a white and bluish double, so you got 2 components, about 30 arc seconds apart. The white component is about mag 4.4, where the blue component is magnitude 7.9. So the blue component's fairly dim. So again, you need like a 8-inch scope probably to see the blue component. And
nice.
That's about it for that poor constellation. For the fish there. Actually, I do use Fomalhaut to get me up towards the Helix Nebula, which we'll cover in a little while.
Okay.
It's kind of like when I'm hunting that down or star hopping, that's the point I start star hopping at.
Got it. So finding
Fomalhaut,
this one.
and then kind of work my way up from there to get to the Helix. But we'll talk about that in a second.
Yeah. Do you want to move on to Aquarius?
Yeah, let's go to Aquarius, the water bear. It's a guy, holding a big jug of water. Actually, he's spilling it out. Some of the old constellations have him spilling it into the mouth of Piscis Austrinus, the southern fish.
Oh.
But a place where I normally start, and when I'm scanning that area with binoculars, is the Asterism, which is the water urn, or kind of a Y-shaped, or maybe a Mercedes-Benz Y-shaped pattern, which you may have to, yeah, there it goes. There was one star missing, now it's there. Kind of a propeller or Y-shape or Mercedes-Benz.
Here.
Zeta is the center star, and then you've got Pi, Eta, and Gamma are the stars surrounding it. It all fits in about a 4-degree circle. And that asterism, when you scan that area in binoculars, it fairly well stands out, so it gives me a good starting point to go after the Aquarius constellation.
Mm-hmm. So that's right up in here. Here's Aquarius. These are some objects we're going to be looking at. But this is what Kent is talking about in this area right here. Okay, go for it, Kent.
Yeah, I figure we need at least one asterism.
Yes, we do. Okay.
And the next one is a really neat object called the Helix Nebula, and it's way down in southern Aquarius. And it's an amazing object. It's one of the nearest planetary, probably the nearest planetary nebula to us. It's very large. It's like 16 arc seconds by, 16 minutes by 12 arc minutes. So it's good sized. It's, the largest diameter is a little bit larger than, half a full moon. So that's pretty good size.
Wow.
And because the moon itself is 30 arc minutes across. And right now they've got a number of like 650 light years for the distance. Also, it's magnitude 7.3. And at our club star parties at the KOA camp, I could easily pick it up with binoculars. So it's, even though it's faint and dim, it's definitely a binocular object.
So how would you hop to it? How would you do that? How would you find
I would go starting with Fomalhaut.
Let me get the moon out of the way. Hang on, let me change the date a little bit, and that will get the...
Oh, push the moon out of the way?
Yeah, let's push the moon out.
There you go.
Perfect. Okay, so normally the moon's not going to be there. Okay, so how do we find this?
I usually start at Fomalhaut. I have a pair of binoculars. I go... I go northwest to the next bright star in Piscis Strenus. So you can see that one, little star there. There you go. I go to that one, and then I go up, straight up, going north, up, looking for something that is kind of fuzzy. You can kind of get a rough idea from, you can see it there.
Yeah.
That you kind of go up 1, 2 stars above that one. There you go, and it's right over from it. So
okay, great.
If you scan it with binoculars, it should pop out, especially if you're in a dark location.
Mm-hmm.
Some guys in Texas, there's reports of them in southern Texas being able to see it naked eye.
Wow.
And also there's a young guy in Arkansas that has a claim to seeing it naked eye.
Wow.
My buddy Morris Clark in Western Australia, it gets overhead there, so it's not down low. It gets way up high. He uses it as a weather indicator, kind of like how we use, the Precept or Messier 44 in Cancer. Yeah, if you can see it naked eye clearly, you've got good clarity, no storms are coming in. But if you can't see it, it means that your sky isn't that clear. And so, unfortunately, I never gave that a try when I was down in Western Australia. In fact, I may have been the wrong time of the year when I was down there.
It might have been.
To actually go for that.
Yeah.
And but yeah, I've seen enough reports where I believe, it can actually be seen naked eye. Not around here.
Nope. All right. So just to, there's one more object here that you wanted to point out, right?
Actually, we got a couple.
Okay, great.
We have to go back up more towards the Y, and there's M2, which is a beautiful globular cluster in Aquarius. It's magnitude 6.4, so it's easily found in a pair of binoculars. It looked like a bloated star. It's about 41,000 light years away, has about 1.5 million stars in it, and it's about 190 light years across. It looks wonderful in my 20-inch. It's got a tight core to it, and then gradually it expands outward. It's just really a beautiful globular cluster. It was discovered by Jean Dominique Moretti on September 11th, 1746, and it's also 5 degrees north of Beta Aquarius, and so
I was just going to ask how you find it.
Okay, there's Beta. There, you put there's Beta, and another thing you'll notice, Alpha is up there near the Y.
Yes.
It's the next bright star, and if you can make M2 pulsate, you'll see M2 forms a right angle triangle with Beta and Alpha.
Yeah, let me highlight it
Aquarius.
again. There we go.
Yeah, that's roughly like a right triangle there. And so, you can either go up from there or just kind of imagine the right triangle and look in that general area. But in binoculars like 750s, you'll see a star that looks too fat. and that's how it looks. It looks, you're going like, that's a little too fat. That must be the globular cluster. Because there's several stars around that area.
Yes.
If you blow it up, there'd be several candidates. But it's the one that's fatter than the rest.
It does look fatter.
So that's what I use to go after M2. It's a beautiful object in an 8-inch scope. I mean, if you have good seeing, just up the power on it.
Nice.
And be all, it's really nice. If you have super good seeing, you'll be able to go right to the core and get a lot of little pinpoint stars right in the core.
Wow.
And so that's a really nice condensed globular cluster.
Nice.
And so you want to go to the next object?
Yeah, let's do Saturn.
Okay, this is the Saturn Nebula.
Yes.
NGC 7009. It was discovered by William Herschel on September 7th, 1782. And it's like his first deep sky object that he ever found. And its magnitude's 7.8, so, it's not a naked eye object. It's about 3,200 light years away and has a size of 30 arc seconds by 26 arc seconds. There's some really neat Hubble photos of this. It's also got, you've got the blobs on either end.
Yes.
They call those ANSIs. It's the extension on there. The reason, it turns out that William Parsons, the 3rd Earl of Rose in Ireland, called it the Saturn Nebula. He gave it that nickname because of those extensions out there. And I remember one time at one of our club star parties, the scene was exceptionally good. And one of the members was saying, "Hey, Kent, take a look at this. I think you should up power on it." I had my 20-inch on it, and I upped the power quite a bit. And you could see the extensions with the knobs on both ends. That's the only time I've been able to do that.
That's amazing. So it probably it probably looked like maybe like this in your 20-inch?
Yeah. Look, you could actually see the knobs on the ends, which blew me away.
That's amazing.
They're kind of like antenna. They call them ANSIs.
Yeah.
But they're the little extensions that are going out. And you can see the nice green central area, too. You can definitely see color on that with the 20-inch.
Wow.
And so it was, that was an exceptional night that we had that evening for the star party. It was a KOA camp. And so the Saturn's just a really neat planetary nebula. An O3 filter makes it stand out, or even like a UHC filter will make it stand out very well. And there's a star called New Aquarius that Aquarii that I usually start at, and just kind of go straight over west about 1¼ degrees, and that'll help me get to it. So, yeah, you've got new there, and we were seeing it. There's new, and you slide westward 1¼ degrees, and it's in there. I guess the graphics doesn't make it pop out.
Yeah, it doesn't unless you're like right there. Okay, so here, let's find new.
It's not very far away. Yeah, new's actually pretty easily seen. You've got beta up above there, and so you drop down to new, and then you just kind of go straight west from there, and you'll should see it as a little fuzzy blob in binoculars if your eyes are good, but I usually just scan with my scope.
There we go.
There you got it. Yeah.
Okay. There we go. So, great. Go ahead. There's another one that's nearby, right?
Yeah, there's another globular cluster that's a nice one. Messier 72, and not far away either.
Yeah.
It was discovered by Pierre Merchain on August 29th, 1780. Has a magnitude of 9.2, so it's fainter. It's about 100 light years in diameter, and it's out there a ways. It's out 58,000 light years. So it's a faint object in binoculars, but if you have like an 8-inch scope, it'll stand out a little bit better. Also, if you look at Mu, we were looking at new Aquarii, but Mu, it's about 3.5 degrees south of Mu Aquarii.
Oh,
so you just kind of drop down about 3 degrees, and you'll get the globular there roughly.
Oh, I don't know where Mu is. We didn't. Let me see. Hang on. Let me put it back in here. Okay, tell me the directions again.
Okay, from Mu, it's 3 point. In fact, you've got it centered on the globular, right? M72.
Yes, this is M72.
Okay, you want to go north then, about 3.5 degrees north to get to Mu. So Mu's that relatively bright star.
Not this one.
Probably that's Mu if I had to guess. If I'm wrong, then it's that one that's a little bit to the right of that one. Or you went left.
Wrong. I did
that
go left.
One. See, that's
there we go. That's
bright.
Mu.
That's Mu. Okay.
Yeah.
If you take Mu, drop it down. It's not exactly, but it gets you into the area.
Okay, so let me back up with Mu highlighted, and then we're going to do a little review here because you covered a lot of stuff. Okay, so here's I think that was it for this constellation, though, right?
Pardon?
That was all we were going to do for this constellation, correct?
Yeah, we had 4 objects for Aquarius, so that's the most for a constellation that we're covering.
Okay, so wait, hang on a second. Don't do any more. Okay, let's do a quick review so you guys can actually use this stuff. Okay, so here we are. We're looking north. We've covered nothing to the north. You walk outside. It happens to be super dark. You see the Milky Way. Lucky you. Okay, so you're going to look south. I did take the moon away so you could use this information for more than just tonight.
Right, and you can use Jupiter and Saturn to start with.
Yes, and do you see Jupiter and Saturn here? They're really bright. You're going to look southwest and see them here. And then you're going to see this line of stars. Do you see that? And so that's the back of, do you remember the first constellation we covered with the sea goat? Okay, and so what were some of the objects we had? Do you remember? Here, wait, don't tell them, Kent. I want them to remember. So we had the little tail. So this is Alpha that we talked about, and this is Beta. And then let's see if we can find M30, the globular cluster. So here's the backbone. And do you see the triangles? I'll highlight it in about 5 seconds. See if you can see the triangles first. If I zoom in a little bit, maybe you can see them better. Okay, do you see the triangles? Here's the tail, there's the horns, and there are your triangles. Now, where's M30? Do you remember? Okay, we're gonna look right in this section here. So a little bit right up in here. And if you can see a little fuzzy patch. Do you see it? It's right there, right off his nose. Good. Okay, wait, don't say anything yet, Kent. We're gonna go find that really bright star, and we're gonna go find, let's see. All right, so now we're looking south, and you're gonna find that really bright star that he was talking about. How do you pronounce this star, Kent?
Fomalhaut.
Fomalhaut. Okay.
It's a horrible name, but
Horrible name. Like my
that's
latte.
the best. I may be really butchering it badly, but that's what I've always known it by, Fomalhaut.
Fomalhaut, like my coffee. It just has a lot. Is foaming a lot. Perfect.
Yeah, I mean it's an Arabic name, so
Yes.
you know, who knows what it sounds like if you had an Arabic speaker translate it for you.
If they could tell us, that would be great. Okay, so we're looking for a loop of stars, and Fomalhaut is the one that's the most in this direction, most to the left. So you're looking for a circle of stars. That's going to be your fish. And do you remember where we saw the next object? We were talking about Beta. Okay, so if we make that circle of stars, it's going to be here. Beta is going to be this one that we had talked about before. Okay, and then we also used this particular constellation to help us find an interesting object. And actually, I can see it right here. You see it right there? So if you're out tonight and you see this loop of stars, and you take that second star and you go up, you'll find the helix, which is this guy.
And in fact, Aurora, if you look at the pattern around the helix, it's like a diamond pattern if you look at the brighter stars.
Yeah, it
See how
is.
There's like a little diamond pattern there. And so you kind of go up a couple stars, and you've got that diamond pattern. That's what I look for in my binoculars.
Oh,
And then I can pull in that fuzzy guy there.
Nice. Perfect.
Where
Good
the
job.
old, the Helix Nebula stands out pretty good that way.
Yes, it does. Okay, so, and then Aquarius. Now, where is Aquarius? Aquarius is kind of a big constellation. So here we are. We're looking south, and we've got our two planets over here. We found Capricorn, which is over here. We found our Pisces here. And now we're going to look up, and we're looking for that Y. Do you see the Y anywhere? I'll tell you in about 5 seconds. See if you can find it. You see it maybe up here? Can't tell me if I'm doing the wrong thing.
Yeah, you're doing it right. That's
okay, good.
That's the Y, or the urn.
This is the Y.
Water urn.
That's right. And so we're going to look for M2 over here. And then, let's see. Let's connect the dots so you can see it. There we go. There's our Y. Okay. And then the other objects, there were two of them that were kind of close together. And if you kind of take that Y and you kind of follow that line, let me make the lines go away. So here's the Y, and you kind of take this line until it goes way down here. And when we saw those other two objects, they were just below that line. So you want to just scan with your binoculars right in this area, and you'll be able to find them. And we talked about using mu and nu to find the Saturn and M72. So here, if I put those constellation lines back in, here we go. Okay, so you'll be looking right in this area. Okay, how'd I do, Kent?
You did good. You missed one, though.
Oh, no! What did I miss?
M2. Remember M2?
Let me go back up.
On Aquarius?
Let me go back up. Okay, here. M2. There we go. Wait. What's it really going to look like? They're going to go outside, and they're not going to be zoomed in. Hang on. All right, so how do we find M2? Okay, so go ahead.
Yeah, one nice way, you've got the Y. Once you find the Y, the bright star just over from the Y to the right is Alpha, and then you angle down, the next bright star is Beta Aquarii. So there's Alpha, angled down, you're getting closer to Beta. Beta's actually off a ways. This would keep going to the south. There you go, there's Beta. So you got Alpha, Beta. Those actually stand out pretty good. And then you kind of go up from Beta, and you can actually hit that fat star in there, which I think I can actually physically see it on there.
Can you see it on here? Here, let me highlight it for
everybody.
everybody.
I can actually see it, M2, as there it is. So you just kind of go up from that. It's about 5 degrees up from Beta.
Nice.
And also it forms like a right triangle with Beta and Alpha.
Nice. Perfect. Awesome. All right, so how are you guys feeling so far? Is that something that you can use, yes? All right, so we have 2 more constellations we're going to be doing. And again, if you just popped in, this is Aurora with the Central Coast Astronomical Society. I'm here with Kent Wallace, and I'm here with Brian Cox. We are taking you on a tour of the night sky, something you can go outside and look at tonight. So the next one, oh, and if you have any questions, make sure you type them in the box. I notice our astronomers have been very busy answering lots of questions. So thank you, all of you CCAS members. Thank you, Dave. Thank you, everybody. I think I saw Glenn on there. Thank you so much. Okay, so let's go take a look at a monster. Do we have any monsters up in the skies?
Cetus the monster.
All right, let's go see if we can find the monster. Let's see if I zoom out a little bit. Okay, so what are you going to tell us about the monster?
Okay, Cetus, that one ties in with the Clash of the Titans that we did a while back with, Perseus, Andromeda, Pegasus, Cassiopeia, and Cepheus. But this was those guys were together. This is way to the south, but this is a sea monster that was ravaging the coast of Ethiopia. It's also referred to as the whale, but the ancient part of it is the sea monster. I think they also, in one of the movies, they called it the Kraken. It's like release the Kraken to attack Ethiopia. And so that's our monster, Cetus.
Got it. Okay, and what is one of the things you see first when you look at this for this constellation?
Actually, when I physically look at it, there's the bright star way over to the right called Beta Cetus. That's a fairly bright star in Cetus. And I don't really talk about it much in our handout here, but that's Beta Cetus. The other one is Alpha Cetus, which is on the far side. There you go. There's Alpha Cetus. And if you drew a rough line between the two, maybe about a third of the way along from Alpha, there's a interesting star called Mira, which means wonderful. And what it is, it's the very first variable star that they ever discovered. It's like a red giant that's gone through the pulsating stage. It gets, bigger and smaller. And when it gets smaller, it gets dimmer. But you can kind of see how it's roughly in line with Alpha and Beta Cetus. I think Mira was at maximum in early October. So it'll be heading down now. But, it's a neat variable star. It's the very first one that they ever discovered. It varies between the 3rd magnitude when it's at its brightest down to the 9th magnitude. And it does it over a period of roughly 331 days. So it's what they call long period variable. It was first noticed by David Fabricius, who saw it fade from maximum in 1596. He thought it was a nova. Later on, it was actually plotted in a naked eye atlas called Uranometria, produced by Bayer in 1603. He's the guy that put all the Greek letters on the stars in the constellations. So in 1603, he plotted it as a 4th magnitude star, not realizing it was a variable star.
Oh, wow.
And, it would either get brighter or outright disappear over a few months. And so, it got picked up on that. They didn't realize what it was.
Huh.
And then let's see, this was before the invention of the telescope. So the telescope came along in 1608. Mm-hmm. And in 1638, the periodic nature of Mira was discovered by Hawadara, I think is if I'm pronouncing it correctly. And it's been followed through maximum and minimum ever since. And it was actually discovered a century before the 2nd variable star, which is Algol. Remember that one? Mm-hmm. It was like the eye and the head of Medusa.
I do.
that Perseus was carrying. And Mira is also about 400 light years away. When it's at its minimum, it's about as bright as our sun.
Oh, wow.
And when it's at the maximum, it's quite a bit brighter. I forget how much brighter it is, but it is quite a bit brighter. Yeah, 250 times
as bright as the sun.
bright.
Wow.
Also, at its maximum, it swells up where its diameter is larger than the orbit of Mars. So it gets quite large. Then it'll shrink on down.
Wow.
And, there's a cool thing about Mira also, is as it's plowing through the interstellar medium, it's losing material also. And in the ultraviolet, they can see a long tail hanging off.
Oh, yes.
I don't know if you can pull up that APOD image on...
I did. I had that. I put it in the handout. Let me find it now. You can keep talking.
It's kind of a neat image because it's like leaving a trail behind it as it's plowing through the interstellar medium, which is, close to a vacuum, but it's enough to pull material off of it.
Yes, here it is.
There you go. You can see it's, kind of mixed up there on the right side there. Mm-hmm. And you can see this long tail behind it.
Yes.
And in fact, if you look at the front, you can see a bow shock wave.
You can.
The kind of curved area there.
Yeah.
And that's where it's pushing material as it's streaming along through the sky.
Awesome.
And so Mira's, it's an interesting object. Mainly, it's a variable star, but it's a classical variable star. It's the first variable star ever discovered. So that's a neat thing about Mira.
Oh, that's wonderful. Okay, great. We were going to talk about, there was another object. Which one do you want to do first?
Okay, we'll do let's do the NGC 246.
Okay.
The Skull Nebula, which is a planetary nebula. I usually start at beta and go up from beta to try and find it.
So here.
And it's a planetary nebula. It's good sized. It's like 240 arc seconds by 210. So it's roughly round. It has several stars embedded within it. It's about 1,500 light years away. To me, it looks more like a grape in my 20-inch with the stars being seeds in the grape. It really doesn't look that much like a skull to me in my 20-inch, but a O3 filter makes it really stand out. It's also magnitude 10.4, and the central star is about magnitude 12. Mm-hmm. And there's one easy way of finding it, and that's by going to two stars, which are Phi 1 and Phi 2, which are kind of above it. And basically 246 and those two other stars form like an equilateral triangle. And so, you got them there. There's Phi 1, Phi 2, and you can see it forms an equilateral triangle with it. So one way of finding it is go directly between Phi 1 and Phi 2 and then drop down from it. Or I guess in this is drop sideways.
Oh, yeah. It's
all depends on where it is. If it's straight south, you drop straight down.
Right.
But that's one easy way to find it.
Well, let's take a look if we back out. Here, I'll put it on here. If we back out, it's right above. You were just saying it was right above beta, so...
Yeah, the problem is the orientation of the images there.
Yeah.
It's if you manage to move Cetus exactly straight south, then that would be going north
straight
out of
north.
there.
Mm-hmm.
The problem is we're looking at it where it's aligned over to the east.
Yes.
And so it's in the rising phase.
Yeah. Okay, great.
And so that gets 246, and then we've got one more.
Yes,
which is our first galaxy.
Yes.
Which is M77 in Cetus. It's about 47 million light years away, so it's a long ways away. Magnitude 8.9. So if you had big binoculars, you could pull it in, but 750s, you might be able to see something, but it'd be tough. Mm-hmm. You have to have good eyes. It's about 100,000 light years in diameter, so It's roughly the same size as our Milky Way. It was discovered by Pierre Merchain on October 29th, 1780, and it's located about 52 minutes east-southeast of Delta Cetus.
So let's take a look. So we actually have this. Do you want to talk about this guy?
Oh, yeah. Forgot about the circlet. I just blew right past
Yes, you
that.
did. That's how I find it.
Yeah. I just blew right past the circlet. So
here,
yeah, I mean,
go ahead.
The circlet is cool. It's, it's another, asterism. It's, there's no bright stars that are 5th and 6th magnitude, but they form a circle, which is kind of cool. And that's in, actually, we're jumping ahead there. We're getting to Pisces now. That's actually in Pisces.
Yes.
And the circlet is something when I'm scanning that area, Pisces has no really bright stars in it. And so the circlet's a neat way of picking it up with binoculars. And the circlet's actually above Cetus. You actually should go up to the Great Square in Pegasus. And it's on the southern side of the Great Square. You kind of drop down. In fact, I can see the circlet. It's actually to the right of the Great Square. You can see that the second fish, or the fish to the west, and that makes up your circlet there. There's the Great Square.
Yep. And then we're going to go down.
Which is always cool.
And
that really bright star there's Mars.
Yes.
Which is in Pisces right now.
Mm-hmm.
And then you've got the little circlet there. They show it as a pentagram. 5-sided, but it's actually 6-sided.
Right.
For the circlet Pisces. And you're circling the wrong
I'm circling the wrong one. Look at me. I'm sorry. I was paying attention to a couple of questions that came in. I'm so sorry.
Oh, okay.
So here we go. That was the monster.
That's the tail of the whale.
Sorry. Let's go back up. Let me circle that again. Okay, so tell us all about the.
There's you got it there. That's the circlet, which is supposed to represent the western fish.
Mm-hmm.
And I don't know if it's Aphrodite or Cupid, one of the two. And then the other fish is actually just a lousy triangle. It's not even as good as a circlet on the other end with this line tying the two together. And I have no idea what the mythology of having the two fishes tied together with a line like that. But, it doesn't have any bright stars in it. It's got that rough V shape, which it goes all the way down and then back up. So you can actually follow that in a pair of binoculars. If you have like a H.A. Ray book and a red flashlight, you can kind of follow it down and then back up. And you can see the Great Square up above it, which looks like the Great Diamond at that point.
It does. It kind of...
Yeah, it can be a square shape or a diamond shape depending on orientation.
Mm-hmm. And it just
as it gets higher and higher, it becomes more of a square.
Yeah.
But that's the circlet in there, and then we've got a galaxy.
Yes.
With Pisces, which is M74, another Messier object. You can see it's on the eastern side of Pisces, and it's magnitude 8.5, about 25 million light years away, so it's a little bit closer than M77, and it's about 77 light years across. It was discovered by Pierre Merchain in September of 1780, and it's located about 1.25 degrees east-northeast of Eta Piscium. Oh, there's a nice image. You can see the H2 regions on there.
Yeah.
That's actually a really nice image. The guy that took that picture, if he was an amateur, was doing a really good job.
It is amazing what amateurs are doing. It is absolutely amazing. Okay, and so to find this on if you don't have your dots connected, so we're going to be looking about east. And then what are you looking for marker stars?
If actually, I would get the V in there, and then probably try and find that Eta star, Eta Pisceum.
Okay.
And then I would slide to the east from that, and try and go a little bit. In this case, it'd be a little bit south. I said east northeast, but it looks like it's southeast. But again, has to do with the orientation of the sky at the time.
Yes.
If this image was directly set up so the constellation was dead south, I think it would be northeast. But yeah, you start with something you can recognize. I'm a star hopper.
Yes.
If you have a go-to scope, you just, get the coordinates, put the coordinates in, which I don't give you, and you have to dig those up yourself, and the galaxy will pop in. The thing about star hopping is with your binoculars and your charts, you really get to learn the sky better.
Yes.
Than, relying on the computer to do all your thinking for you.
That's true. That's true. And you get to know the star patterns better.
Oh, yeah. Yeah, you get a lot better appreciation. It all depends on whether you've got a good memory for patterns.
Yes.
Some people have excellent memories for patterns, and they can, once they see it a few times, they got it down. And some people just can't hold a pattern in their head, and that's what go-to scopes are for.
Yes.
And, go-to scopes are really cool because then they can find stuff. They just have to have a list of the coordinates, which would be right ascension, declination.
Yes.
And I think we've pretty well polished off our
I think we did it. Yay! So how was that? Did you enjoy it? Okay, let's take a look. One more quick review so you know exactly what you're looking at. So Kent, let's go back maybe south. Here, so this is what the moon is going to look like tonight. I put it back for tonight.
Got the moon in there. You've got Jupiter and Saturn, which are real good pointers.
Real good pointers.
Since they're pointing at the goat there, the sea goat, which is Capricorn.
Just right in here. Do you see it? Can you find Capricorn? Okay, I'm going to put the lines in. 3, 2, 1. Did you get it? And now you're going to look off his nose. You're going to look at the doubles, I guess, on here. And yeah,
you got actually 2 doubles there. Actually, the nice one is the alpha one up the top of the tail there, because that's, if you have good eyes, you should be able to split it.
Yes.
And it should be a real easy split, and even like a 750 pair of binoculars.
Yes. Now in your handout, this is what you have. So you have Capricorn, and I've circled the ones that we covered for tonight. And then here's M30, and this is what it looks like. So you'll be able to see it off the nose. Okay, let's go find the fish. Where's the fish? Can you help me find it? Okay, here we go. Let's get rid of all the pretty little dots, or not the dots. That would be really hard to get rid of the stars. Okay, so let's take a look. So we found our Capricorn. We found our Saturn and Jupiter. We found Capricorn here. We found a really bright star. If we kind of look in here, let's see if I can get some of the stars. There we go. Do you see a loop of stars in here? Okay, and if we come and connect them, you'll see this. And the handout that you have will show you, we talked about alpha and we talked about beta. And that's right in there. And then Kent also shared with us a way to find the NGC. Is the number 7293? Is that right?
Yeah, 7293, or the Helix Nebula.
Yes, the Helix Nebula. So you're going to go up here, and then you're going to go up. Oh, I can even see it here. And to give you a sense of scale, let's see if I can. Stellarium really doesn't like nebula, so I think I'm just going to have to type it in. 7293, there. Okay. To kind of give you a sense of where it is, there's that really bright star that we talked about. And thank you. Brian looked up how to pronounce it, and thank you to everyone who helped us out. They were saying that the correct pronunciation... Hey, actually, Brian, are you there? We haven't even said hi to you yet.
I'm here. You said hi at the beginning.
I did.
Yes.
We did. How do you pronounce that star?
That's foam-a-lot, or foam-a-low is the secondary pronunciation.
Foam-a-lot and foam-a-low. Perfect.
Foam-a-lot. Good enough.
All right, don't go anywhere too far, Brian. We're going to bring you back on.
Right.
Okay, great. And so let's see, where were we? Oh, yes, we were finding the helix from foam-a-low, foam-a-lot. Okay. And then the next set in our handout, Aquarius had a lot going on. The first thing I want you to find is the Y. Can you find it? Okay, so here's Capricorn, here's foam-a-low, the Pisces down below. And do you see the Y? Kind of just really stares at you here. And then
I know how to remember foam a lot easy. Just think of a beer with too much foam on it. It's got foam a lot.
Or root beer.
Yeah,
yes.
There you go.
How about some root beer? There we go. Okay, so once you've got this, you've got the kind of the shoulder neck area. Or no, actually in this case
it's the urn.
It's the urn.
There, the water urn.
Yes. Okay. And then you have that. And if you look back on your handout, you'll see something like this. And this will give you a quick guide. M2 is right up here. What was the name of this middle star, Kent?
Beta.
This was Beta.
You got Alpha is the one closer to the Y.
Yes.
So, there's Alpha, the bright one there. Then you just kind of slide over, and there's Beta.
And we can look at
M2. You
M2.
go up to M2 from Beta.
And then we also had, if you slide further along the arm, we had the Saturn Nebula, and we had M72, and they're real close together. Okay, great. And then the last ones we were doing the monster. Okay, so can you find the monster? He was more south, at least for this time. There we go. Okay, there we go. I put him here. So we're looking for, he's still a little too further. There we go. Now I see him. Okay, so he's going to be pretty close to Mars tonight. So if you look east, kind of southeast and east, you're going to try to find his head. It was a circle of, I think it's 6 stars. Is that right?
That's actually his tail, but Alpha tail? Is there.
There it is.
You've got Alpha, kind of like that six-sided object, and there's Alpha. But usually it's depicted, his head is up near Beta with his tail. Of course, they got it reversed on that one.
They do. Okay.
But the HA ray image would have it. That's the problem with them superimposing pictures.
I know.
on the sky is that people have their different interpretations on how it should look.
They do. So we're going to connect.
You got Alpha and Beta are the 2 brightest ones.
Yes.
In Cetus.
And then we're going to look about a third the way over, and we'll find the variable star that you were talking about. That was the first one discovered,
Mira,
right?
which is the wonderful, means wonderful.
So right in there.
Probably in Italian or something like that.
And then a few other objects which are on your handout is M77 as well as NGC 246. So right above, depending on which way the whale is facing for you, which way you really like to see the whale. So you're going to look right in here for M77, and then the skull or the raisin or the grape is going to be right over here. Good. And then we had one last little one, right? We had...
Right, which is Pisces.
Yep. So once you find this constellation with those 2 bright stars, you're just going to go straight up, and you'll see you're going to be looking for a V here. So here we go. Okay, you can kind of see these 2 really bright stars. Mars will be in Pisces right now. And then you'll see a V that comes in, and that's what we're talking about. And this was the circlet that Kent was talking about, where I was circling part of the whale. So here we go. And the object that M74, you're going to find that right here. Okay, great. So how was that? You now know some things in the night sky. Yay! Can you use this? Yes. All right. So first of all, I want to say thank you so much to our astronomers. Thank you to I've seen Tom Smith out there tonight and Dave Majors. Thank you so much for helping out with answering questions. And we're actually going to take some questions. Brian, do you want to maybe have some questions for Kent that have been coming in that you're thinking might be good for Kent to answer?
Sure. Well, we did have a question that came up a while ago on asking what is a nebula.
Oh, Kent, this is your question.
Okay. Actually, yeah. I mean, for deep sky, you've got stars and nebulas, and nebula comes from Latin, means cloud. A lot in the old days, a lot of the globular clusters and things like that were listed as nebulas because the telescopes couldn't resolve the stars in the globulars. Later on, when they got better telescopes, you could resolve them. And for a while there, they thought all nebulas were resolvable into stars. But it turns out William Herschel questioned that towards the end of his career. And it turns out that if it's made out of gas or dust, there's a lot of different forms of nebulas. You can have supernova remnants like the Crab Nebula. That's probably the most famous supernova remnant, where you had a massive star blow up. My favorites are planetary nebulas, and there's a whole mess of them in there. And they're more like the gentle deaths of, more average stars like our sun. The supernovas are fairly rare, but the planetary nebulas are all over the place. I think they've cataloged almost 3,000 of them in our galaxy. So there's, a lot of neat ones. They have neat shapes. So the Hubble's been really great for getting a lot of pictures of the different morphologies of planetary nebula. You've also got H2 regions where stars are being born. And those can be, relatively small or gigantic. The ones that, we think of as an easy one is like the Great Orion Nebula. That's where stars are being born. And so, that's in what they call an H2 region or a star birth region. You've also got Dark Nebula, where you've got actually a tight ball of mainly carbon dust blocking the starlight. And they can be really small or good size. One of the biggest ones is the Sac Nebula next to the Southern Cross. Another good one that you can see from here is above the Scorpion. They call it the Pipe Nebula. And if you have a really nice dark night and the Milky Way's up high, you can actually follow the dust lane that cuts across the Milky Way. And it goes all the way from the Southern Cross to the Northern Cross. And in a lot of pictures of galaxies that are edge-on, you can see the dust lane cutting across it. And that's mainly carbon dust for the most part. And so that's a few of the nebula. But they're the cloudy objects. And, there's a lot of different types. There's Wolf-Rayet nebulas. There's a whole mess of weird Herbig-Haro nebulas. there's a ton of different types of nebulas depending on how you classify them. And so hopefully that'll answer the question for the person.
Awesome. Thank you. I was racing desperately to find images of everything you were talking about. I got maybe 2/3 of them, and I apologize. When I put M16, I didn't get a nebula, so I fixed that right away. So, but yes, you can actually look. One of the best places to look is the Messier Catalog. Would you agree, Kent?
Pardon, what was that?
So if you're new into astronomy and are interested in taking a look, the Messier Catalog would be a good place to start.
The Messier Catalog is, that's really the beginner's catalog, and we all start with the Messier objects. And there's a good mixture of globulars, star clusters, and galaxies, and all the sorts of different nebulas. whether it's Planetary Nebula. About the only thing they're lacking is for dark nebulas. But then he didn't really care about dark nebulas. But
No.
the showy stuff is in the Messier Catalog. Sometimes you have combinations. You have clusters embedded into nebula. And so, the Messier Catalog is a place to begin.
Awesome. Thank you. Perfect. That was a great question. Okay, and let's see. One of the questions that came in. Brian, do you have other questions that you would?
So, the questions all branched off of that nebula question, and Kent, you covered them all with your explanation, so you did a great job with that.
Oh, great. Thank you.
Yes. And so I have one pending equipment question when we're ready for those.
Yes, I was going to say that those are the next set of questions I see. And let me see. There's one other question I saw earlier about the planets, why some planets are higher than others, like why Mercury and Venus don't get very high. Did you want to talk about that, Kent?
Yeah, I mean, it's kind of funny because they're roughly all in the same plane. It's just where they're located along the ecliptic. The ecliptic is a line that runs, that's actually the pathway of the sun. And depending on the time of night or the time of year, the ecliptic can be higher and lower. About the only thing that really is kind of wonky, probably more than the planets themselves, is our moon. I think our moon's got like a 6-degree tilt to it. And so it gets a little bit higher up off the ecliptic than most of them, or it can get down lower. And so it may look like a planet is high, and it will be high in your sky, but then if you wait for a while during that night, it's going to set also. It'll drop down and go lower. But I'm sure there's some really minute differences because they're not all exactly in the plane 100%.
Sure.
So some will be up a little bit higher in the plane of the ecliptic. But I don't know if you can even notice it with the naked eye. And so that's, one difference. For the long-term time span, I came across something. Remember about how the North Pole isn't always Polaris? It's been different stars. Well, it turns out there's a big circle that takes 26,000 years for that big circle to turn. And it turns out that when the pole star is farthest, let's see, is it north or farthest south? Yeah, I think it's farthest south. When the pole star is farthest south, you have more of a southern horizon. Turns out about 3,000 years ago, the Greeks had a wonderful view of Centaurus, and, they could probably see the Southern Cross from Athens.
Whoa.
And we can't do that now because, 3,000 years have gone by, and the ecliptic, or the precession of the equinox has moved up to a high star, which is Polaris. And so over time, it turns out the southern horizon from, this altitude or latitude actually changes. But you got, I'm talking about really long time spans.
Yes.
So I don't know if you've ever thought about that or not.
No,
but
I hadn't
kind of
even
an interesting
considered that.
thing.
So this is our horizon now, and this is what Kent is talking about. Well, it's nighttime, so the sun is below the horizon. But he's talking about Centaurus, which is here.
Yeah, Centaurus. See, Centaurus is one of the ancient Greek constellations.
Oh, so how could they have possibly not seen it if they...
Right now, our limit is Upper Centaurus. We can see Centaurus or Alpha, let's see. We can see not Alpha Centaurus, but Omega Centaurus.
Yes.
Omega Centaurus, which is upper back of Centaurus. But I mean, back in the old Greek days, they could see quite a bit further south.
Wow, that's amazing.
If I understand all this, and that's why you see all these, stars that we can't see now, but the Greeks had them as constellations.
Wow, it's really interesting.
Same thing with the Argo. which is the ship that they split into 3 chunks.
Yes.
That's Puppis, Corinna, and Vela, the sails. And, that's one of the ancient Greek constellations is Argo, which is the Jason and the Argonauts, the ship that they took to go get the Golden Fleece. And so I think I wandered off topic a long way.
That's okay. I'm still trying to pull it up. I accidentally shut off all of Stellarium. So here we go. So this is what Kent was just talking about right now, how this was a huge, well, right now it's upside down, but
it's upside down, but yeah, you can see the front of the ship, the Puppis, then we've got Corinna, which is like the keel of the ship, and then Vela, the sails.
If we turn off the pictures, you can kind of see it.
There was a guy by the name of, I think, De La Calle that decided it was kind of awkward being so monstrously large that he split it up into those 3 pieces. And, we're living with it today. Got locked in about 1930, I think.
Yes. Awesome. Well, thank you. Wow, you are just an incredible wealth of knowledge. If you guys enjoyed tonight's presentation, drop Kent a note in the comments section. We copy those and send them to him if you would like to know. If you let him know specifically what you enjoyed about tonight's presentation, that would be really, really helpful. So, Kent, is there anything else you wanted to share before we sign off for tonight?
I think we've covered quite a bit of stuff. We've run a little bit over time.
That's
normal,
okay.
But we always do that anyhow.
We do. Well, go ahead.
Unless you've got any more questions for me.
Let's see. Brian, did you have any other questions?
No, I think we're good.
Okay. I think there's just 1 or 2 equipment questions that I think Brian and I can probably handle. And I think that's it, just from Brian and myself and everyone out there. Kent, thank you so much for sharing your passion and your excitement about and your knowledge about the astronomy and the dark skies, and really, really appreciate it. So thank you.
Thank you very much, Aurora, and
you're welcome.
Thank everybody else out there for tuning in.
Absolutely.
You all take care and have a good evening.
Thanks.
I'll see you later then.
You got it.
Okay.
Bye, Kent.
Bye.
All right, Brian, it's you and me now. Woo.
All right.
We're going to try to field some equipment questions.
And I really just have one that's come over as far as from text or chat.
Yeah.
And that was when a person asked what kind of tripod or stand you'd recommend for larger binoculars. Like they use the example of 20 by 70s.
Oh, yes. Do you want me to answer? How about you? You must have a recommendation.
Sure. Well, for that size telescope, 20 by 70, I would recommend the parallelogram mount. And
I have one. You keep talking and I'll go get it.
And so what I mean by that is we talk about having a tripod, which you could be used to seeing from a regular camera, right? 3 legs with a head on top. With a parallelogram mount, you actually have then an apparatus on top of the tripod that allows you to mount the binoculars, and then you can point them at an object, and then it'll actually hold it with that object. Another nice thing as Aurora's getting it into place is you can have people of different heights look at the same object without having to change where you're pointing. You can actually move that up and down, and it will hold this. It'll hold the position. You may not know this, but most binoculars that are worth their salt have a tripod mount. It's a quarter 20 bolt receiver that's, as you can see, right behind the focuser. And that will then, and there's different holders that are available with tripods or then with brackets like on the parallelogram mount. And Orion Telescope has these, a few other companies have them. And you do want to be sure that you get a mount that's designed for the size of your binoculars. Mm-hmm. And you'll notice on the right side of the image, there's a counterweight. And that's very important. Whenever you're moving really any kind of telescope, but also binoculars, you want to have a balanced support so that otherwise, you go to point an object and it's just going to drop down.
Yeah.
So parallelogram mounts, they are a little pricey, but you've already invested enough in binoculars that need it. It's worth it to go that extra mile. And sometimes what I do when I travel, if I don't have room once the whole family's packed in for my 10-inch telescope, let alone my 20, then I pack the parallelogram mount and then my my 20 by 70s, and that holds me over. Especially so there's nothing worse than traveling someplace that has dark skies and not having at least some kind of piece of equipment with you.
Yes. Yeah, thank you. That's really, really important. And these are adjustable. And like the best feature is when you could do this, and it doesn't. You notice it doesn't change. Well, it's got a little wobble in it right now, but because I didn't clamp everything down. But it'll go up and down, but it won't change the angle. It'll still stay centered. It's really handy for things like small children when they come up and they say, "I want to look." And then you have the guy who's 6'2" that comes next and says, "I want to look," and you're like, "Okay, hang on." So, and when binoculars start getting above, for me, it's like beyond these are 10 by 50s, and 50 is, let's see, the diameter here in millimeters. So I don't know is it too far away? So this diameter here in millimeters, like this is 8 inches.
We could see
so this
it.
would be
I think
50
it's
millimeters. So what did I just say? 10 by 50s. So if they're much bigger than that, my neck starts to hurt, and it gets to be too heavy to hold the image steady for more than the first one or two objects, and then I'm just done. So this makes it easier, so I can stargaze much longer, like all night long. So all you have to do is add hot cocoa and tripod mount, and then we're good. So, okay, great. Awesome. That's a great question. And along those lines, if you are interested in going beyond just looking with your naked eyes, binoculars are the way to go. A lot of people just skip over this step, but it's the best way to get started in astronomy. It's inexpensive. Celestron has a pair of 7 by 50s that are, I think it's called the Cometron. You can get them for $30. And they're fantastic for astronomy. And you can go all the way up. Really, the thing you want to be careful of with binoculars is if you're buying like a used pair, for example, like at a swap meet or something, just make sure that they do focus, and make sure that nothing rattles, because otherwise just put them down. But other than that, you can't go wrong. And binoculars are great also for kids because they're used to looking with both eyes. If you have small kids in your family, a lot of times closing one eye and looking through the other is difficult. It's a difficult skill to master. And then you got to get your eyeball right up there, right up to the eyepiece, and a lot of people are uncomfortable with that at first. So this really gives a lot of good practice to those skills. And then the next thing that you do after this, if you've mastered this, then you go to a star party. Before you even buy a telescope, go try everybody's telescope out. And this is going to happen when we have star parties again. Just go and find as many telescopes. Which one do you like the design of? Which one are you just not comfortable with because the eyepiece is like clear up by the ceiling? So you get kind of a feel for what it is you want to look at. That will determine what kind of scope you're going to get, and what your conditions are. Like, where do you live? If you live in some places you'll never see deep sky objects, getting that type of telescope is not going to be great. You might want to look at something else. If you have kids, you want to get a Dobsonian because the mount isn't up here, it's down low. They're not going to be able to knock it over. It'll be easier for them to maneuver. So there's a lot of things to think about. There's no one size fits all. So a lot of our astronomers do start out with Dobsonians, and I don't know if you noticed that image I shared in the beginning with Kent, and also Brian has a Dobsonian. A lot of people don't like them initially because they don't look like a telescope, right? Back me up on this. They're not up on a rickety stand. They're huge. They look like big buckets, and they're way down on the ground. But the scene is so good, and you can
Call them
what's that?
Bucket. They even call them light
buckets. Yes, they do. And compared to typical reflectors, Schmidt-Cassegrains, which are amazing, right? You can get so much more for your money, especially when you first get into the hobby. Dobsonians tend to be less expensive. Whew, how was that for an equipment talk? You want to add anything?
Yes, very good. Well, I would like to point out a couple things. First, I would share, Rory, you've actually made a separate video all about binoculars, so I invite everyone to go and look at that one.
Yes.
And remember that in our handout, we have on the last page, equipment recommendations along with some links. And we did have the question come up, as does every time, on what do the two numbers mean with the 10 and 50. And so I'll say really quick, in case people aren't able to read the chat. First number is magnification, and second number is the aperture opening going in millimeters. So if they were 10 by 50, that means 10 times and a 50 millimeter opening. So the larger that opening, the more light it lets in.
Yes, the better it is. The more expensive it is, the more strain on your neck it's going to be. So if you have lawn chairs, just sitting outside with this, like Kent was talking about, recognizing star patterns is the way to go. And so really just having time, looking up at the night sky, getting familiar with those patterns, using your binoculars, looking at the books, looking at the charts, and it just takes time, just like anything else, but it is so worth it. Any other questions that you've got coming through that you want to cover?
No, I think that is good.
Okay. All right. Well, thank you, everyone. And thanks for joining us tonight. You know what you need to do now. You need to go outside, look up, and enjoy the night sky. Take as much of this knowledge with you. This recording will be available, so you can watch it as many times as you want. Do pass it along to your friends. If you have anyone you think is even remotely interested in the night sky, please share this link with them. And also like us on our YouTube page. You can become a member of CCAS. Join us that way as well if you'd like. Our website again is centralcoastastronomy.org, O-R-G, so centralcoastastronomy.org, and you can find out more about us. We do these monthly stargazing tours of the night sky just because we love sharing our passion with the community, and so this is one of the ways we've been doing it. We've actually been doing the online stargazing since March, so we're going to continue to do this format. Next month's stargazing session, write this down on your calendar, is December, help, December, today is the 21st. 19, there we go. Yes. December 19th, so write that down. December 19th is our next stargazing event, and that is one you do not want to miss. I have been waiting all year for the thing that's going to happen in December, and we're going to tell you all about it. And I think the last time it happened was what, like 600 years ago, or I forget when, probably a couple hundred years ago at least. I need to look it up, but and so I've been waiting all year for this. It's just going to be so incredible. So we are going to be talking about that, and so we are excited. So thank you, Brian. Brian, say goodbye to everybody.
You're welcome. Thank you. Bye, everyone.
Goodbye.
Thanks for joining us.
So goodbye, everyone, and I will see you next time. If you have questions, let us know. You can always reach us at questions@centralcoastastronomy.org. And so have a wonderful night, and we hope to see you soon at a stargazing event. And do share this with other folks, and let us know what you thought of tonight's show in the comment box below. So go ahead and do that now. I will see the rest of you next time for December. Take care, everybody. Bye-bye.